Okay. This is one of the frappies from the Chapter 8, 2018, number 2. Do you regularly recycle? Alright. I don't know. Environmental science teacher. Science. Glorified religion. High school with a large population. Why do they say that? It's for the independence part. Estimate. Oh, proportion. Thank you. So it's not automatically going to be easier, but it's just going to be less rigmarole. Random sample. Random. Let's hope it was a simple random sample. And each selected student went into the teacher's office one at a time. That sounds inappropriate. And was asked to respond yes or no to the following question. So, this teacher got these kids alone in the office, just scared out of their wits, obviously. Let's see if we can, as they say in the world of morons, let's circle back to that one. We're gonna get this all squared away, as the blowhards say. Oh, nice. They give us the confidence interval. Okay, so looks like we're done with the problem, huh? How many students were in the sample selected by the environmental science teacher? All right. 584-816. It was 95%, and it was a proportion problem, so great. We know the z-score already, 1.96. So it looks like we're working backwards. So let's see. If we need to know sample size for a proportion, looks like we're looking for this thing. P hat, because remember we don't know the population. And then 1 minus p hat over n times the z, 1.96. And then we need that, it'd be nice to know the x bar. Oh, it's a proportion problem. It'd be nice to know the p hat. How do we find that? Well, p hat's going to be right in the middle of those two things. So find the average of those two numbers. 584,816 averaged. Calculator. Could probably do this in my head quicker. This is ridiculous. Let's see. 84 and 16 make a whole. 8 and 6 make 14. 1.4 divided by 2 is 0.7. That's easy. So p has 0.7 plus minus 1.96 times square root of 0.7, 0.3, and we don't know. Now, there's a few different ways you can go about doing this, but remember, this part is your margin of error. Margin of error is also the amount we add and the amount we subtract to get our two extremes. So I would just use that. It looks like the margin of error is 0.116. So 1.96 times the square root of all this nastiness, that's 0.21 over n. Let's just call it equals 0.116. And now we do algebra. Divide by 196. Square that. 6 divided by 1.96, enter, squared, enter. So, oops. 21 over n equals 0.003503. Whatever, I don't know what's important. So I'm going to keep some more. Multiply both sides by n. Boom. So 0.21 divided by that thing. 59.95. Alright, what was the question? How many students were selected? I don't know. I'm going to say 60. I honestly don't know if in this case we should round up or down. I'm going to keep it with my round up. Just trust the gut. My gigantic Corona gut. Alright. B. Talking about bias. Oh. This probably goes back to the kids being sequestered in this office. Explain how bias might have been introduced and describe how the bias might affect the point estimate. Who respond yes? Do you? Okay. Do you recycle? So, kids get called into the office. What am I getting called in here for? I'm so scared. And then this strange science teacher, they're all so strange, says, do you recycle plastic bottles? And at first you're a little relieved because you didn't know what you were about to get asked, but then all of a sudden you're not so relieved. Now you're back on edge because, like, why are you being grabbed privately, brought into an office, surrounded by all these weird textbooks and skulls of rats and birds and bones and beakers to answer a question about plastic bottles? And you think to yourself, if I say no, that rat skull might be the last thing I see. So guess what you're going to say? You're going to say yes. Yes, of course I do. So, the bias, I don't know how to describe that bias. Maybe creepy teacher bias. Creepy teacher bias at play. So I named the bias. Now you tell how this bias is going to change the results that you would normally get. Kids might feel pressured to say yes, they recycle for fear of death. This environmental teacher. And then, okay, so therefore I'm going to use the words they said, point estimate. Therefore, point estimate probably higher than if maybe it was anonymous, than if it was unanimous. I think that covers it. Talk about the bias, why the bias would affect the way they answer, and then how that's going to affect the results. Okay, part C. So, the statistics and then here comes, someone with just some really good sense to save the day. Statistics teacher was concerned about the bias. Statistics teacher used an alternate method for collecting the student responses. No, first of all, remember, according to this teacher's results, wow, far more than 50% of the students said they regularly recycle plastic bottles. But the statistics teacher, knowing how weird that science teacher remains this teacher is going to do something about it. And so, random sample of 300 students. I'm sure it was a simple random sample. Each student was given the following instructions on how to respond. In private, flip a coin. If heads, you say no matter what. Tails, you answer honestly. And then what's the expected number of students who would be required to respond no? What was the no's? Would be required to respond no. Okay, so the only people that are required to respond no are the heads people. Expected number. This is a I've got a new piece of paper. This is a continuous random, it's a binomial, but we're going to do a binomial estimation. So, according to the binomial estimation, expected number, can you see that? N times P. That gives us your expected value. So N was 300. Probability of flipping if heads, you must respond no. Probability of flipping the heads, we're going to expect 150 would be required to respond no. Okay, bingo. That's all you guys show. 150 required to expected 150 required to respond no. Okay, and the results doing it this way show that 213 of the 300 students said no. Okay, remember some of those were forced to say no. Based on the results of the sample, give a point estimate for the proportion of all students at the high school who would respond yes. So don't let this fool you, this all students. If you do your sampling correctly, that's what you're going to get. You're going to get an estimate for the proportion of everybody. If your sample was taken from the whole population, a simple random sample from the whole population, then you can make a conclusion about the whole population. So don't freak out about that. Give a point estimate for the proportion of all students who would respond yes. So we got to do a little rough justice here. So I'll do something like this. 213 total no's. Okay. Now I'm going to subtract off the 150 who had to say no, which leaves 63. This no's? Yeah. 63. Let's call them natural no's. Okay, let's see what we do with that. So 63. So that means out of the other 150 kids, 63 of them actually said no, they don't recycle, which leaves, the hell, 87, which leaves 87 kids that said natural yes. All right, so based on the results of the sample, give a point estimate for the proportion of all students to high school who would respond yes to the question. Since that 150 where they had to say no is like worthless, so forget about it. Let's pretend that wasn't even part of the process. So we're just going to have to go off of the other 150 that was truthful. So out of 150, 87 out of 150 would respond yes. So since I give a point estimate, point estimate, you can leave it like that. Or you could actually divide it. I don't know what it divides to, and I don't care, but I'm going to figure it out anyway. 87 divided by 150. Oh God, this stupid calculator. About 58%. About 58% of the school would respond yes. Would respond in the affirmative. And that kind of pisses me off because... Oh, no, it's not. Good. 58%, according to this made-up statistics teacher's research, 58% is not within the interval, so obviously this guy's interval is bogus. No, you're bogus.